the conjugations are very similar.
Anyway,
Anyway,
not hard. Just remembering the end and what end is where.
yeah, I mean, it is a more difficult language to learn for an English speaker than Spanish, for example, but it's not super difficult. All right, anyway, moving on. So remember that the midterm covers up to and including lesson 51, which had done the lesson set on there were some questions asked about some of the questions on that homework regarding lesson 51. So I want to finish going over together 51 because I wasn't here for us to do that together. So turn in the textbook to page 205, lesson 51. Remember that here in 50 and 51, we're talking about this thing. What do we call this thing?
Coordinate plane.
The coordinate plane. So it's a plane, it's a flat two-dimensional surface. That's what a plane is. It's a flat two-dimensional surface that goes forever in every direction. Just like a line is a two-dimensional, is a one-dimensional space that goes forever in both directions. A plane is a two-dimensional space, dress code, that goes forever, dress code please, that goes forever in all four directions. Across, you can remember that because the letter X looks like a cross, and the y-axis is then at 90 degrees to it, and that's vertical. Okay, and it's called the coordinate plane because each point on this plane, just like we have points on lines, we also have points on planes, can be described using coordinates, or one of these things. What do we call this? When we've got these two values, an x value and a y value,
I don't think I was
separated by a comma.
Sorry.
Squeeze it steady.
Separated by a comma. What do we call this? When we have our coordinates written like this, what's the term for that? It's two words. The first one starts with an O.
Coordinate.
Or take a look at the book. This is from lesson 50. This is review.
Origin. Organized.
Look at 51. 50. Look at lesson 50 there.
Ordered pair.
An ordered pair. Thank you. Because it's a pair of values, and they're always in a particular order. Which one always comes first?
X.
Right. And the way that you can remember that is it's just alphabetical order. That's so nice of them to do this logical thing for you. It's almost like math makes sense most of the time. An ordered pair. And any ordered pair describes a point on the coordinate plane. The x value, that first one will tell us where it is, left or right. If the x value is negative, well, first of all, what do we call this point in the middle where they meet? Yeah, the origin. The origin. If our x value is negative, which direction am I going to go in from the origin?
You're going to go down.
Which way?
Left.
Left. If my x value is positive, which way am I going to go?
Right.
If my y value is negative, which way am I going to go?
Down.
And if my y value is positive, I'm going to go?
Up.
All right, great. So that was what we talked about in 50. These are also called quadrant. The four things here are called quadrants. They're numbered 1, 2, 3, 4, usually using Roman numerals. You don't need to know that for the midterm, but it is a good thing to be aware of. But these are your four quadrants. So you start, the first quadrant is the one where they're both positive. That makes sense. It's the most commonly used one for real-world applications. And then it goes counterclockwise, or as the Brits say, anti-clockwise, or as I like to say, widdershins, which is an obscure word meaning counterclockwise. You go there, you go widdershins, you go counterclockwise in order 1, 2, 3, 4. Okay. Anyway, that's just a good thing to be aware of. All right. So now, what does this have to do with algebra?
Graphing points.
Graphing. Okay, we can graph individual points on here, particular combinations of x and y. So what this will let us do is this will let us represent equations where we have more than one variable, specifically where we have two variables. One variable is what? X, and the other one is y. Normally when we have an equation, if there's only one variable, there's just a single answer. Once you have two variables, though, because those are both changing, imagine that you have this equation. Okay, x equals 5. How many solutions are there for that?
There's a lot.
Like
X equals 5? There's only one. The only value of x that makes this true is 5. Okay, what if we have this equation, though? X plus y equals 10. How many solutions of that are there?
4 or 5.
There are an infinite number because we can, for any value of x, it doesn't matter what x is, there's always some y value that we can add to it to make it equal 10. If x is 0, y is 10. If x is 1, y is 9. If x is 2, y is 8. If x is 11, then y is -1. It doesn't matter what x is. Any value of x, we can find a solution for that equation. And it's equations like that where we have two variables, and so therefore an infinite number of solutions, where this is going to become useful. Because we find that even though there are an infinite number of solutions, all the solutions have a relationship to each other, which we'll see in a moment. So let's talk about how we can represent different equations visually and see all the solutions visually using the coordinate plane here, or the Cartesian plane is the other thing that it's called. Now, when we're graphing equations, unless we get really far in the book this year, we're only going to be dealing with first-degree equations. Okay, first-degree equations. What does that mean, a first-degree equation?
A number with one, like the exponent is 1.
Right, the highest exponent on any of the variables is 1. Something raised to the first power. First-degree equation, also known as a linear equation. And it's called that because if we graph the solution to a first-degree equation, it's going to look like what? What do you think? Going by the name. It's going to look like a line, a straight line. Well, a line, mathematically by definition, is straight. Not always. When we have powers above 1 on our exponents,
Second degree.
like a second-degree equation or a third-degree or fourth-degree equation, then it's not going to be a straight line anymore. It's going to be curved in one of a number of different ways. That's not something we're going to get to probably at all this year. We might get a little bit to at the very end of the year, depending on how far we get. But that's really beyond the scope of this course. What happens when you have a second or third-degree equation?
You think we're gonna?
That's more of a pre-calculus kind of question.
You think we're gonna get through all the problem sets?
No, generally we don't. I like to get up to 100, and we're on track more or less to do that. Last year I got up to 80. That was decent.
If we don't finish all of the problem sets, is it gonna be like something that
No,
we do over summer?
no, because as you get on, there's some overlap between the different books. The end of this is going to be concepts that are really more relevant to later courses. So if we get further, then you'll get an earlier introduction to that stuff, and you'll get a bit ahead. But otherwise, no, it's not going to hinder you from continuing on, unless we really didn't get far. Like if we got to 50, if this is as far as we got in the year, yeah, then you'd be behind. But you don't have to get all the way to the end to stay on track. All right, so linear equations. Let's talk first about two special types of equations that we might graph. What if we have something like, what if we only have one variable? So let's say, what would x equals, this is really where, hold on, let me get another color marker here. Oh, all right, so, marker gremlin. All right, so what if we have something like x equals 4? How would we graph it here? If this were a number line, you listening? If this were a number line, what would x equals 4 look like?
X would be somewhere where the 4 is.
Yeah, we'd have this here. Now, when we have the coordinate plane, we're looking for all the points that solve it. So here, this point, x is equal to 4, yes?
Yeah.
What's y equal to right here?
8.
0. Okay, what about here where x is 4 and y is 1? Does that still solve that equation, x equals 4? Yes. What about where y equals 2 and x is 4? Does that work? What about where y is negative 10 and x is 4? Yeah, it doesn't matter what the value of y is. As long as x is 4, that'll work. So this equation here, x equals 4, the solution for it when we graph it is going to look like a vertical line. Because as long as x is 4, it doesn't matter what the value of y is. Y has nothing to do with this. Y could be 70 billion. And as long as x is 4, it still works. So notice, it is a line. It goes forever in both directions. Forever and ever. It goes to infinity and beyond. All right. Yes? So when you only have x in an equation, the graph is going to look like a vertical line. Vertical line. Similarly, what if we have this equation, y equals negative 2? What's that going to look like when we graph it?
Somewhere with
There's
a
gonna be a
line.
line left to right on the negative 2.
Right, a horizontal line, because here, y is negative 2 and x is 0. Okay, that's a solution. But it's also a solution if y is negative 2 and x is 5, or if x is 10, or if x is negative 17. It doesn't matter what the x value is, that y value of negative 2 will always be a solution for that equation, y equals negative 2. Yes?
Yes.
Okay, so if we only have x, our solution will be a vertical line. If we only have y, it'll be a horizontal line. Questions so far?
This is left in 51.
This is 51, yes.
Wait, why don't we have a test there?
It was scheduled for yesterday, but I flaked. That's why.
So are you gonna have the?
No, we're just gonna have the midterm.
Thank you for not being like this.
All right. What if we have equations that have both x and y?
Then you create a point.
Right. So there are a few different ways that we can find the graph for equations that have both x and y. If it's just x or just y, it's easy enough. Either a vertical or horizontal line. If we've got both, there are a couple of different methods. The first method we'll start out with is by making a table. So let's pick an equation here. Let's just do the one that they have here in the book. So example 51.1 at the top of page 206. So we're going to graph this equation. I'm going to use blue this time. Where'd my blue go? There it is. I'm going to use the blue marker. And the equation that they want us to graph is y equals 2x minus 1. The way that we're going to graph this, you know, I dropped it. It fell with style. Why am I making Toy Story references today? All right. Y equals 2x plus 1, minus 1. We're going to make a table like this.
See, it's foreshadowing.
And we're going to find at least 3 points. Actually, technically, we look at this. What kind of equation is this?
Equate.
What kind of equation is it?
Linear.
It's a linear equation, so its graph is going to be a line. Technically, we're only going to need to find 2 points, because any 2 points is only one line that can go between them. But let's try to find 3, just to make sure. And then if our 3 points aren't in a straight line from each other, we know we did something wrong. You can find more points than that. Yeah, so the easy way to do this, if you want to find 3, is set x to -1, 0, and 1.
Yeah.
What? Because those are easy numbers to work with.
Would it be 2?
1, 2, 3.
You can use 0, 1, and 2. 0's a good one to include, though. I would always include 0. So, now we're going to solve this equation plugging in these different values for x. And notice that the y value will change depending on the x value. So if x is, let's do the easy one. X is 0. If x is 0, what's y? Well, 2x minus 1. 2 times 0 is 0, minus 1 is -1. All right. What about if x is 1? Well,
-1.
no.
Negative 2?
No.
0.
Okay, if x is 1, 2x is what?
It's gonna be 1.
If x is 1, then what's 2x?
2.
2. Minus 1 is?
1.
Okay, thank you. What if x is negative 1?
Two.
-3.
Two.
Yeah, it's negative 3 because 2x would be what?
-2.
2x is negative 2 minus 1 is
-3.
negative 3. All right, now what we can do is notice we have 3 different sets of x and y values. We could think of these as ordered pairs. So what's the first ordered pair that we have?
X equals -1, y equals
How would we write that as an ordered pair, like this, x comma y?
-1, -3.
Negative 1 comma negative 3. What's the second point that we have?
0, -1.
0 comma negative 1. What's the last point that we have?
1, 1.
Okay, 1 comma 1. We're going to graph. Are you paying attention?
Yeah.
Sorry, let me rephrase that. Please pay attention. We have these 3 ordered pairs, these 3 points that we can now graph here. Negative 1 comma 3, negative 1 comma negative 3, 0 comma negative 1, and 1 comma 1. Do you see where I got this information from here? You can pick any 3 values for x. You can even go and you can pick values for y. But generally picking values for x is going to be the easy way to go. As long as you find at least 2, preferably 3 sets of things that make this equation true, that solve it, then you'll be able to graph it properly. I like to use negative 1, 0, and 1. Why? 0 is easy to use, 1 is easy to use, and negative 1 means that we're going to have a negative value also that's easy to use. So let's graph them first. So negative 1 comma negative 3, where would that be? So I start at the origin and I go where?
Down 1.
No. I go which direction? I go left 1 because our x value is negative 1, and then I go
Down 3.
down 3, 1, 2, 3. So there's the first point. That's negative 1 comma negative 3 right there. Remember the x value is always first.
And now 0, -1.
Well, my second one, so I start at the origin and I go where?
Down -1.
Yeah, I don't go left or right at all because it's 0, and then I go down 1. And then for my third point, I go where?
Up 1, right 1.
Well, so let's do it in the correct order.
Right 1, up 1.
Yeah, I go right 1 and then I go up 1. Okay, I've got these 3 points here. Those look to me like they're in a straight line from each other.
I did it all by myself.
So that looks great. What I can do here is I draw a line between them. I draw arrows at each end. Why? Why do I put the arrows at each end?
Because it's infinite.
Because it goes on forever. You could have any solution along this line will work for it. Then the best thing to do is then you also label it. So this is y equals 2x minus 1. Notice how I also label it? That's a good practice to get in.
Yeah.
Okay, so 3 things there. 1, I made my table and found my points. Then I graphed those points on there.
And then you label it.
I checked my work. Notice by having 3, I can check my work. If these 3 didn't look like they were in a straight line, that either means I did some math wrong or my drawing's way off.
Yeah.
But here these look very much in a straight line. And then I can draw a line connecting them with arrows at both ends, and I label it. Yes? Questions about that? Let's do another example. Let's do another example.
I like ravioli.
Let's do so go to page 209. Go to page 209. Let's look at the practice ones there. So I'm gonna let's see, I'm gonna erase my horizontal and vertical lines here so we can use red and green again.
Here we go. Here we go.
What?
Part of the story.
Yeah, it's a boat.
It is.
All right. Let's do A. Actually, let's do all 4 of these. Let's do all 4 of these. I'll erase this guy too. Let's do all 4 of these practice ones here together.
Yeah, no, right.
Is there a problem? You seem to be having a lot of conversations in the back there.
Yeah, it is.
Do you have your textbook open to page 209? Let me rephrase that. Please get your textbook open to page 209.
Yeah.
All right, let's do all 4 of these practice ones here. Let's start with, let's just start at the beginning. So first off, somebody please read practice A for me there.
Practice A. On
Yep.
209.
Yep.
Y equals X.
Oh, I see.
Negative
Yeah.
X plus 1.
Y equals negative X. What color do you guys want to use for this one?
Blue.
Blue, all right, we'll start with blue. We'll do Carol House first. Yeah. Y equals what?
Negative X plus 1.
Okay, Y equals negative X plus 1. Y equals negative X plus 1. What kind of equation is this?
Linear.
How can you tell that it's a linear equation? It is a linear equation.
Because Y equals, you gotta find Y.
Okay, here's something that isn't a linear equation. Y equals negative X squared plus 1. That is not a linear equation.
Because it's square.
Second degree, right?
Okay, yeah, because it's second degree. This one is a linear equation because why?
They're not exponents.
Because it's first degree. Because our variables are only raised to the first power. Y to the first and X to the first.
What was the third degree?
Third degree, you have a cube there, like X cubed minus 2X squared plus X plus 4. Okay, it's a linear equation. So, is it a vertical or horizontal line?
Vertical. No, horizontal.
Is it one of those two?
No.
How can we tell that it's not vertical or horizontal?
Because it's supposed to go diagonal.
Right, because we have both X and Y. If we have only X or only Y, then it'll be either horizontal or vertical. But here, since we have both, it'll be sloped. So how can we graph this equation, this linear equation, which is going to have a sloped line as its graph?
You want to do like a little box?
We're going to do a little box thing, a table. How am I going to set that up?
Y
X
over X.
Or
I recommend staying in order,
Yeah,
like in
Y
alphabetical
over Y.
order. So let's do X on top and,
Y on bottom.
okay, then what I'm going to do?
Line. And then 0, 1, 2.
Okay, let's do 0, 1, and 2. Great. For our X values. So now what do I do with those X values?
Alright, so for 0 it's gonna be
1.
What's going to be 1?
Y.
Y is going to be 1. How'd you get that?
Because 0, negative 0, that doesn't exist. So it's just 1.
When negative 0 is still 0, plus 1 is 1. All right, what if X is 1?
It's gonna be 0.
Is 0, because negative X is negative 1, plus 1 gives us 0. And what if X is 2?
Negative 1.
Negative 1. Everybody see how we got those Y values from these X values?
Yeah.
Yes?
Yeah.
Okay, now what are we going to do with that information?
Go to the origin.
We're going to go to the origin, okay? And we're going to graph them, right?
Yeah, you go down 1.
What?
You're gonna go up 1.
Okay, I'm going to go here. Yeah, for my first point, I'm just going to go up 1. Because X is 0, so I'm not going to go to the left or the right. Then I go up 1. All right, what about for my next point?
You're gonna go right 1.
Right 1 and not up or down, because Y is 0.
Yeah.
And for my third point,
You're gonna go right 2.
2 to the right and
Down 1.
down 1. Now let's check. Does that look like a straight line to you, those three?
Yeah.
It looks like it to me. So what do we do now?
For the line here with arrows.
Okay, line through it with arrows on either end, and we should
Label it.
label it. Label it what?
Y equals negative X plus 1.
Yes. Y equals, let's do here. Y equals negative X plus 1.
Is that the only?
Can I go to the bathroom, please?
That is the only answer you can get for that.
Can I go to the bathroom, please?
Okay, yes, but please in the future, you get here early enough that you can do this before class starts.
Yeah.
Go. Stop with the commentary.
Bro, you literally show up late and you're not even in bed.
Yes, there is only one line that graphs the solution to this equation. There are an infinite number of solutions. There are an infinite number of points along this line, but it is only that line. Any point here that's not on that line is not a solution to this equation. This is the only possible solution to this equation. All right, let's do B. What do we have for B? I'm going to read B. What color do we want to use for B? Calvert, Stewart, or Washington?
Albert.
Calvert, all right. B, we're gonna do Calvert.
Y equals negative 1/3 x plus 2.
Okay, y equals negative 1/3 x plus 2. What am I gonna do here? What kind of equation is this, first of all? It's a linear equation. Is it horizontal or vertical? Is it either horizontal or vertical?
I mean, yeah. No.
No.
Yeah.
How can we tell it's not horizontal or vertical?
There's a fraction.
Not because of the fraction, because it has both x and y. If it only has x, it'll be vertical. If it only has y, it'll be horizontal. But this one has both x and y, so it's going to be sloped. Okay, so what do you have to do to graph it? Yeah, make this chart. What's on the top row?
X,
On the bottom?
Y.
Now, when we're picking our x values, let's be smart about it. Notice what's happening to x in this equation? Being multiplied by negative 1/3. So let's pick some x values that are going to give us nice round numbers as our answers. So what's always a good option for x? Always a good option. I always recommend that you use 0. Okay. What else are we going to use?
17 and 6.
Remember that we want to use x values that are going to give us something easy to work with when we multiply them by negative 1/3.
Oh, negative 1.
So we can use 3, because 3 times a third is 1, and that's nice and easy to work with. What else would be a nice convenient x value to use? 6 would be great, because 6 times 1/3 is going to give us 2. So you could do this by picking 1 and 2 as your x values. You can pick any x values you want, but make your life easier for yourself. Look at the equation and ask yourself, what am I going to be doing to x? And so what values can I pick to make my life easier? Okay, so with 0, 3, and 6, what's y going to be if x is 0?
Negative 1/3.
No. Yes, 2. Negative 1/3 times 0 is?
You lost it.
Okay, so
0.
first we're going to do with x is 0. So we need negative 1/3 times 0, which is?
Exactly. Anything times 0 is 0.
Okay, plus 2 is?
17.
0 plus 2 is?
2.
Is 2, yeah. Okay, what if x is 3? What's negative 1/3 times 3?
Negative 1/3. 1.
Careful.
Wait.
Negative 1.
Oh, negative 1.
Negative 1 plus 2 is?
1.
1. Okay, what if x is 6?
0.
Negative 2.
Negative 2
Plus 2.
plus 2 is 0, right. Notice how we got nice numbers there. If you pick something that isn't divisible by 3 for x, you're going to get a fraction as your answer. You can still graph that. It's just going to be harder to graph it accurately. All right, so now let's plot these. So where's my first point going to be? Where do I go?
Up 2.
I just go up 2. My second point, where am I going to go?
Right 3.
1, 2, 3, and
Up 1.
up 1. My last point, I'm going to go?
Over 6.
I'm going to go, yep, over 6. 1, 2, 3, 4, 5, 6, and just right there, not up or down. Do those three look like they're in a more or less straight line?
Yeah.
Yeah, okay. So then we can do what?
Line.
Draw a line between them. Let's see if I can do this accurately. That looks pretty good. And then I do what?
Label it.
Label it. Label it y equals negative 1/3 x plus 2.
Yeah.
Questions about that one?
No.
Okay, let's do the last two quickly. Stewart or Washington?
Washington.
Washington, all right. So C, what's the equation for C?
X equals 3.
X equals 3, all right.
It is Washington.
This one, just like all these other equations, is linear. But what else? What else do we see? Notice about this one, X equals 3.
It has no Y.
There's no Y, so what can we tell about the graph of this equation?
It's going to be at 40.
Be careful. If there's only X, then the graph is going to be, the line is going to be, no.
Linear.
Okay, let's try this. Let's try this. Let's do one of these things.
Oh. Yeah. So
Okay, if y is 0, what's x going to be?
3.
3,
If y is 1, what's x going to be?
3,
If y is 2, what's x going to be?
6,
3.
3, that's fine.
X is always 3 here. So, now if we try to graph that our first point, where's it going to be?
Right.
Right.
Right?
3.
And
You're
that's it. Where's the next point going to be?
Over 3.
Up 1 over 3.
Okay, and then our last point?
Over 3 up 2.
Okay, so if you only have x, then it's going to be vertical. X equals 3. The y value does not matter for this. That's the terrible way to write this. Let's write x equals 3.
Yeah.
Be careful. It's easy to get mixed up here and think x, that's your horizontal axis. So if I only have x, it's going to be horizontal. No. Because it's that horizontal distance that doesn't change. If x is 3, then the x value, where it is, left or right, never changes. But it doesn't say anything about how far up and down, about where up and down it is. So there's only x, it's vertical. All right.
It says y equals negative 4.
Y equals negative 4. Okay, what's that going to look like? Y equals negative 4, what's that going to look like?
X over y.
Okay, we don't have to do that.
Oh, okay. So then.
Why don't we have to do that for this one?
Because it's all going to be the same for y.
It is linear.
Or, well, it's just going to be the same for y.
Right. It only has y, so it's going to be what kind of line?
Straight.
Horizontal.
Yeah.
We only have to make the chart if it's got both x and y, if it's sloped. But if it's either only got x and so vertical, or only y and so horizontal, we don't actually need to do the chart. So if y is negative 4, where am I going to draw that line?
You go down negative 4.
Go down 4 and
1, 2, 3,
make a straight line going where?
4.
Yeah, horizontally. Because the x value doesn't matter. It doesn't matter any value of x, as long as y is negative 4, that'll work.
Look at all those colors.
Look at all those beautiful colors. Questions, comments, concerns?
No.
Okay,
So let's just like not do homework.
let's open it up. You have midterms next week. I'm not going to assign your homework. Your written homework. But let's open it up for review. Any questions from any problem set up to and including 51, or any topic from any lesson up to and including 51
Problem set
that
1.
you want to go over? I mean, I'd rather not do more of this right now.
Problem set 1, number 1.
Problem set 51, number 3.
51, number 3. So we're on page 209. Number 3. We're using unimultipliers here. That's a great thing to review
Oh, yeah.
because that's a common area of confusion. That's good. That's good. So let's, I mean, in my experience, like either, once you do them enough, they become second nature. Until that point, easy to make mistakes. So we're using 4 unimultipliers to convert what?
10 kilometers to feet.
Oh, look, they even tell us how to do this. What do they tell us to do?
Go kilometers to meters, centimeters to inches.
Kilometers to meters to centimeters to inches to feet. All right, look at that. Now, don't freak out when you see that you have to make that many steps, that you have to make 4 steps. Take it one step at a time. So, how are we going to start out?
10 kilometers over
10 kilometers over 1. Then what do I do? Times
1,000 meters.
1,000 meters over
1 kilometer.
over 1 kilometer. Now, why did we put kilometers on the bottom there?
Because 1,000 meters is 1 kilometer.
But why did we put the kilometers on the bottom and not the top? Right, because we're trying to get rid of the kilometers up here. We got to get rid of these kilometers, so we put kilometers on the bottom, and they cancel out.
Yes,
So
sir.
we multiply 1 meter on the bottom and 100 centimeters on top.
Right, now we're trying to go from meters to centimeters, so we have to get rid of meters, so we put them on the bottom, and there's 100 centimeters in a meter.
Then do
2.54 inches on top and 1 centimeter on the bottom.
1.
Yes?
Yeah.
So the centimeters now cancel out, and then we do
1 foot on top and 12 inches on the bottom.
And now the inches cancel out. So what's the only unit we have left?
feet.
Is that what we're trying to shoot for?
Yeah.
And then you go
10
10
times
times
1,000 times 100 times 2.54 times 1.
leave out the one,
Yeah, leave out the ones.
and then at the bottom.
Yes. Yeah, and then over 12. Don't forget that. So on top we got 10 times 1,000 times 100 times 2.54. On the bottom we got 1 times 1 times 1 times 1 times 12.
And the unit.
And the unit, don't forget the unit is?
Feet.
Will you please stop clicking that pen?
I'm not. I don't have it. No, wait, I need that. I don't have it.
Feet, don't forget the unit there. Take these unit conversions one step at a time. You could have even done this going from square kilometers to square feet. You would have had to do 8 steps instead of 4. It would have been annoying to write out, but you just follow the same process one step at a time. Yes?
What if you write the answer, but they're in different orders? Like it's 10 parentheses 2.54 parentheses 1,000.
That's fine. I mean, it's still a correct answer, but if your order is off, then that makes me concerned that you're actually making some mistakes here in the middle. Because you have to go in this order, kilometers to meters to centimeters to inches to feet. The only one that you could skip is you could go right from kilometers to centimeters, theoretically.
How do you do that?
Well, because there's
10,000?
how many centimeters are there in a kilometer?
2 or 100. No, it's not 10,000. 1,000.
So there are 1,000 meters, and there's 100 centimeters in each meter. So there are
2,000.
we've got 1,000 meters in a kilometer, right? Each one of those has 100 centimeters in it. So how many centimeters are in a kilometer? 100,000, yes. So you could have done that. You could have skipped. You could have combined these guys together, 100 and 1,000. But otherwise, you really have to go in this order because we don't have convenient conversions. I mean, you could look one up, a conversion between any two of these. Say it again.
It's 2.54 centimeters over 1. Right?
Yeah, wait. Thank you. Yeah, we totally messed that up.
I was looking at it, I was like, that's.
Yeah. Okay. Wow, that's embarrassing. All right. Yes, you're right. What should we have had on the bottom here? No.
Should have had 2.54.
Yes, and on the top we should have had 1 inch. All right, and then here we should have what?
No.
No.
On the bottom.
Yeah, 12 inches on the bottom
And
and 1 foot on top. All right,
Didn't
so
you have that?
no, so we flipped this one around. We weren't careful with that. Where did my red? Here it is. There are too many different places to keep things. All right, so really it should be the 2.54 has to be on the bottom. Thank you for pointing that out. 10 times 1,000. I'm gonna ask somebody to leave.
It's not me.
What?
Over 2.54 times 12 feet. Yeah, the 2.54 has to go on the bottom. Thank you for pointing that out. Yes, this is why you have to make sure you remember those conversions correctly.
told you, I'm good.
Yeah, I mean, I thank you for pointing that out. You should point it out when I make mistakes up here. And your classmates will learn the right thing instead of the wrong thing. Because they're centimeters smaller than an inch. So 1 inch has 2.54 centimeters.
You're wasting more like right so it's not Alex on the next time you do it. I can't really
You could move up closer.
Yeah.
see. Cool.
If you would.
Well, why don't you try that first? All right. Anything else you want to talk about? Which one? Number 6 from problem set 51? Okay, problem set 51, number 6. We're on page 210 here. If 72 is increased by 130%, what's the result? So,
72
What's-
plus 130 over 100.
no, be careful. When we say increased by some percent, we're increasing it by 130% of what?
Itself.
Of 130% of what? So what we really want is we want 72 plus 130% of 72. Yes? Isn't that what we really want?
Yeah.
We're taking 72 and we're increasing it by 130% of itself. When you see a percent, you have to ask yourself percent of what? All right, so then we do this and we get what?
I don't know.
What's 130% of 72?
202
Um,
over 100.
Wait,
no.
wait a minute.
Back.
Oh, it's multiplication or addition? Really?
First we do the multiplication.
Oh,
102.
130, sorry, we simplify our fraction first of all. So we get 13 over 10 equals 72 over 1, times 72 over 1. What's 13 times 72? Or actually we can cancel out first. What can we simplify here? Anybody? What canceling out can we do here? 10 and 72, we can divide them both by?
1036.
What? What can we divide 10 and 72 both by?
I don't know.
Well, what things can we divide 10 by? 2. Can we divide 72 by 2? Yes, awesome. So 10 divided by 2 is?
5.
72 divided by 2 is? 36. All right, so on top, we've got 13 times 36, which is what? Let's just do it.
468.
Yes, 468. So we got 468 over?
100.
Nope.
Oh, 5.
Over 5. Okay, we've got 72 plus that. How are we going to add these together?
Make this number be the
A better way to do that is to make this into a mixed number. What's this as a mixed number? What's 468 over 5 as a mixed number?
92.
92.
Wow, that's
72 plus 92, and what's left over?
164. Oh,
I'm sorry, no, 93. And
155.
notice there's still 3 left over after that. 5 goes into 18 3 times. There's still 3 left overs. 5 goes into 30 how many times? 6, 93.6. We just said 93 and 3/5. And then you add those together, and we get what? We get
Now,
165.6. What's the other way you could have done this? You could have skipped a step by doing this a little bit differently.
72 plus 72 plus 72, 30.
Okay, so there we can add a step and make our lives a little bit easier. So if we're increasing by 130%, first we increase it by 100%, that's adding 72, and then we add 30% of 72. Okay, that'll let us skip a step. So 72 plus 72 is 144, plus 3 over 10 times 72 over 1. 72
36 over 5.
and 36 times 3 is what?
109.
108
8.
over
5.
5. Turn that into a mixed number, we get
20.
when we divide by 5, 5 goes into 10 2
21.
times.
21 with 3 left over.
Yes, 21,
0.3.
either remainder 3, so 21 and 3/5. When you have a remainder, you can write that as a fraction. If there's 3 left over, then that's 3 divided by 5 is what's left over. 21 and 3/5. Okay, then we add it together, and look, we get 165 and 3/5. It's the same answer. Another way we could have done this, which is okay, we could do 1.3. You could do that too. Yeah, 130 over 100, we could read it right as 1.3. Another way that we can skip a step with these ones, if we're increasing it by 130%, what percent of 72 are we going to have at the end of it? What percent of 72 is 72? Is 100%. So if we increase it by 130%, what percent are we going to end up with?
72 over 230.
We're going to have a 230%. It's already at 100%. Then we're adding 130% more.
230.
So we're going to have, we can think of this as 230% of 72. And as you pointed out, this particular percent is probably easier to deal with as a decimal. We can rewrite this as 2.3 times 72. Or you can even write it as 2, and if you don't want to do the decimals, if you don't want to do the arithmetic in the decimals, you could do 2 3/10.
Or you could do 23 over 10.
Or you could do 23 over 10.
And then
Whatever, 23 over 10 times 72 over 1. Either one of these is going to work. This one, though, is probably easier because then we just need to do this. We just need to multiply 72 and 2.3. You guys remember how to do this, multiplying decimals? So we did 3 times 2 is 6, 3 times 7 is 21, 2 times 2, we move over place, 2 times 2 is 4, 2 times 7 is 14. Add them together.
1,656.
Be careful, not 1,000, because we had a decimal here.
Oh, I
One
know.
hundred sixty-five.
Yeah, so we have to have the same number of things to the right of decimal down here as we had up there. We have only one thing to the right of decimal up there, so one thing down here. Any one of a number of different ways that you could do this. But the trick here with this one, the tricky bit, is that if we're increasing by 130%, that's on top of the 100% that it already is. So we actually have 230% at the end of it. So a lot of ways you can do that. But yes, that's the key there.
No, it's
The answer is 165.6 or 165 3/5. Either one of those is fine. And then we can check it by saying, is that somewhere between 2 times and 3 times 72? Yes, it is. It's more than 2 times 72. It's less than 3 times, so that makes sense.
Okay.
Yep,
If I get a bad grade on the midterm,
Yep.
take my grade down, like my grade. Like
Yes.
now,
bye.
like, now.